Okay, so I just wanted to go over some questions from homework one that I saw the majority of people struggle on. Okay, so the first one was this one right here. The prompt was to simplify into a fractional exponent. Okay, so let me just go through this very quickly. So the numerator can be rewritten as a fractional exponent of 1/2. Okay, so a square root is the same as raising it to the 1/2 power. And the denominator, the seventh root, is the same thing as raising to the 1/7th power. Okay? So far good, just converting from radicals to fractions. Next, we need to use our quotient rule. Okay, that's the rule that tells us we subtract the two powers. Okay, so this would be xyz to the 1/2 minus 1/7th power. All right, so this is the step that I did not see a lot of people do. Okay, so this is just the quotient rule, and now you can just subtract these fractions. So you create a common denominator of 14. So you multiply the top and bottom of the first guy by 7/7, and multiply the top and bottom of the second guy by 2/2. All right, so that will be xyz to the 7/14 minus 2/14. Okay, and then since we have the same denominator, we can just subtract across the numerators. So final answer will be xyz to the 5/14 power. All right, so any questions about that one? There were a few people who kind of were seemed a little lost on this question. All right, so I hope that's cool. All right, next one. A lot of people got this wrong. So the question just stated, is this a polynomial? Okay. So we have this expression 5 raised the x plus 1 minus x squared. Would someone like to unmute themselves and explain to me if it is or if it isn't a polynomial?
I'm going to say no because the multiple numbers are in the exponents, correct?
Right. So almost right. So it definitely has to do with the exponent. So in the definition of a polynomial, we require the exponents to be whole numbers, like 1, 2, 3, 4. We don't put variables in the exponent, okay? But this expression I have written here, this has a variable in the exponent, okay? So that violates the definition of polynomial. So the answer is no, okay? And this is actually an exponential, okay? Which we will do later in the semester, okay? This is actually an exponential function. Okay, so because of the variable x in the exponent, that makes it not a polynomial, okay? Last one, so this one, a lot of people didn't even attempt it, which was which was a little upsetting. So to subtract rational expressions or add them, it's just like adding and subtracting fractions, okay? You need to find the least common denominator and then subtract straight across, okay? So usually you can just multiply the two denominators together to get your common denominator, okay? So basically the LCD here is just the product of these two guys. So the LCD is x plus 1 multiplied by 2x plus 1, okay? So now you need to multiply the top and bottom of these fractions to create the LCD. So to go from x plus 1 to the LCD, I need to multiply the top and bottom by 2x plus 1, okay? Minus, and for the second fraction, I need to multiply the top and bottom by x plus 1, okay? I need to multiply the top and bottom of this guy by x plus 1 to create those common denominators. All right, so I hope that's okay. And now you just rewrite this as one big fraction. X plus 1 times 2x plus 1. Yeah, and you can pretty much just leave it like this. You can just do x minus 1 times 2x plus 1 minus, and then just write this factor here. Okay, minus 2x plus 3 times x plus 1. Okay, and then the next step, if you would like, would be to just multiply the polynomials in the numerator. Okay, so the next step would just be now multiply out the numerator. All right, so that would be that question.
You utilize what's it called? Canceling each other out on that, like x plus 1 and x plus 1, 2x plus 1 and 2x plus 1.
Where are you seeing canceling out?
X plus 1 on the bottom,
Yeah.
and then x plus 1 on the numerator.
Yeah, so you don't want it, so fractions can't be canceled that way. And actually, if you were to cancel them, you would just be undoing creating the least common denominator that we did before. So you would just be going back to the original question. So you would be going backwards. Yeah. All right. So that's that. Multiply out the numerator, combine like terms, you would finish that question. All right, so any questions on this? So this is kind of important. You can expect a question like this on the first test. All right, so let's get to tonight's stuff. So we're gonna do Cartesian or a rectangular coordinate system, all right, or like the XY plane. So let's start with the definition here. So definition. So the Cartesian, or sometimes called rectangular coordinate system is a two-dimensional plane, P-L-A-N-E-E, consisting of the x and y axes, both of which are perpendicular to each other, okay? Both of which are perpendicular to each other, okay? So here's the picture that goes along with this. I'm sure this will look familiar. We have our two axes here. They cross each other at right angles. That's what perpendicular means. This is the x-axis, the horizontal guy. The vertical guy is the y-axis, okay? We have this point in the middle that we call the origin, okay? And we also like to give names to these four sections. They're called quadrants. So this guy is the first quadrant, this guy is the second quadrant, and so on, okay?
What makes it two-dimensional? I mean, I know it's not really that important, but just curious.
Yeah, so two-dimensional, that has to do with how many numbers we need to describe a point in the xy plane. We need two numbers. So like the point 2, 3, you need two data points to describe a point here. So the fact that there are two entries, that means two-dimensional.
Okay.
So we have the first, second, third, and fourth quadrants. That will be more important when we do trigonometry later. And this is just a picture. All right, this is what it looks like, okay? So how do we actually get points here? So how do we, like, what does it mean to graph a point? So just quickly, a point in the plane is denoted as x comma y, where x is the horizontal distance, where x is the horizontal distance from the origin, so from this middle point here where the two axes cross, and y is the vertical distance from the origin. Okay, so I'm just being very explicit about how to graph a point xy, okay? And as I said before, the point 0, 0 is very special. The point 0, 0 is called the origin, okay? So that's a very special point. sorry, it's called the origin. The origin. Okay. So hopefully this seems somewhat familiar. I think the best thing to do is just to get some examples going. So let's just practice plotting some points. All right. So let's plot the points. Let's plot these points. 3, 3, -2, 4, and 0, -3. All right, so let's just plot these guys and just see the process for doing this. So let me draw my axes. It'll look like that. Here's the y-axis, here's the x-axis. And I'm just make these little tick marks just to denote like how far I need to go out. So that'll be 1, that'll be 2, that'll be 3. Similarly, 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4. Okay. All right. So let's do the first one. 3, 3. So the first one tells us I need to travel out on the x-axis 3 units and then go up on the y-axis 3 units. So let's do that. So 1, 2, 3 out on the x-axis, and now I need to go up 3 units on the y-axis. So 1, 2, 3. So that is 3, 3. All right. How about the next one? -2, 4. That means I need to travel to the left 2 units on the x-axis and then go up 4 on the y-axis. So 1, 2, and then now up 4. 1, 2, 3, 4. Okay, so that's -2, 4. And then the last one, 0, -3. That means I stay on the y-axis and I just go down 3. 1, 2, 3. And that's 0, -3. Okay, so any questions as to how I arrived at these locations for each point? Was anything unclear? Because this will be very important when we start graphing functions later. All right, so we all need to know how to plot points.
I have a question, but not about like how you arrived there, but like the one that's in the 0, y, is it in which quadrant?
Oh, that's a great question. What quadrant is this in? You know, I would say maybe it's both the 3rd and 4th. Yeah, but that's a great question. I don't know.
Thank you. I was curious.
Yeah, no, you know what? I will definitely look into that and I will get back to you. But my tentative answer is both 3 and 4. Yeah. But I'll definitely look into that because that's interesting. Okay, so that's plotting points. So now let's just do a quick graphing. So let's look at graphing equations. All right, so here's the setup. So suppose we want to graph the equation. It's going to look like this. Y equals, which one are we doing? Y equals x plus 2. Okay, we just want to graph what this equation will look like. And what's the process? Well, we can set up a table of x values. All right, and plug them into y equals x plus 2 to get the corresponding y values. All right. Okay, so let's just be concrete. So what does this actually look like? So basically what I mean is I make a chart or a table. The left column is x, and I'm just going to pick a few x values, okay? And usually what I like to pick are -2, 0, 1, and 2. So those I'm going to plug into y equals x plus 2, okay? And that's how I get this y column. All right, so the y column will just be -2 plus 2. Which is 0. Oh, sorry, I'm missing, sorry, I should have put a -1 here. I forgot that. So it'll be -2, -1, 0, 1, 2. My bad. Okay, now if I plug in -1, I'll get -1 plus 2 is 1. If I plug in 0, I will get 2. If I plug in 1, I will get 3. And if I plug in 2, I will get 4. Okay, so how I got these points in the y column, I just plugged in these x values into the equation x plus 2. All right, and now all that's left to do is just graph these points. Okay, so let's just graph them. Okay, so the first point is -2, 0. So that will look like this, -2, 0. Okay, the next one is -1, 1. So that's going to look like that. Next one is 0, 2. So it'll be like that. Then 1, 3. And then 2, 4. So 2. Okay. Then just connect the dots. All right. So let's see if I can make this look all right. So something like that. So just connect the dots with a straight line. And there you go. You have your graph of the equation. All right, so any questions how I'm doing this, how I got these black dots here? How did I get these points? I'm just reading them from the table, okay, the XY table. All right, so just let me know.
So that would be the linear line, right? From the equation?
Exactly, yes. So we're going to get to that, I think, later. But yes, this is the graph of a linear equation. Absolutely. Yes. Very good. All right. So that's all I'll do now for graphing. Okay. But that I think it's pretty simple. Now let's just talk about some important things called x-intercepts and y-intercepts. Okay. So let's just talk about these quickly. And these will come in the form of a definition, right? So DEF, just recall that means I'm going to write a definition next. All right, so let's define these words. So the x-intercept is the point at which the graph crosses the x-axis. Okay, so at this point, the y coordinate is 0. At this point, the y coordinate is 0. Okay, so that's the x-intercept. It's just the point at which the graph crosses the x-axis. Okay. And then similarly, we have the definition for the y-intercept. The y-intercept is the point at which the graph crosses the y-axis. Okay, and again, at this point, at this y-intercept point, the x-coordinate is 0. Okay, so how about we identify the x and y intercepts for the previous example, okay? So that'll be a good application. So for the previous example, the y-intercept was blank, and the x-intercept was blank. So how about you guys just take a few seconds or a minute and just find out what the x and y intercepts were for the previous example. Okay.
All of it is 0. -2.
Okay. So does anyone want to tell me what they got?
The x was -2 and the y was 2.
Yes, exactly. So the x-intercept was -2, 0. So you can also just put it into its xy coordinate form, like that. And the y-intercept was 2, so 0, 2. Very good. All right, so does everyone agree with this? So this does align with the definition here. So at the y-intercept, the x-coordinate is 0. So do you see how the x-coordinate is 0 for the y-intercept? That's important. And similarly, at the x-intercept, the y-coordinate is 0. And look, at the x-intercept, the y-coordinate is 0. Okay, so we have that nice relationship there. Okay.
Do you have to put it in coordinate form? Or you can just give that number.
I don't see. There's kind of like a debate surrounding, is the x-coordinate, is the x-intercept like the number, or is it the coordinate pair?
Like for instance, in a linear equation, when they have the y-intercept at the end, like for example, x plus 2, they usually keep it without it.
Right, exactly. So it's not. So to me, I don't really care which one you give me. I like to give the coordinate though, because it emphasizes that the other coordinate is 0. So for the x-intercept, the y-coordinate is 0. But yeah, both will be fine.
Okay. Thanks.
Yeah. All right, good. So that's important. Good. So that'll finish that. Now let's go to the distance formula. Okay.
I'm sorry, just a quick question.
Sure.
How wasn't the y-intercept 0, 3?
0.3.
I wrote it down wrong. Sorry.
Okay. Yeah. Good. Yeah. All right. So if no more questions, I'll move on. Okay. So next thing we'll do is the distance formula. Okay. Distance formula. Okay. So I was going to go into some geometrical argument as to how you get the distance formula, but in the interest of time, I think I'll skip that. So let's just get straight to the definition, okay? And then I'll maybe explain it verbally. Okay, so the distance between distance between 2 points. Between 2 points, x1, y1, and x2, y2 is given by the following formula. It's given by. So we usually just denote the distance with the letter D. Okay, that's just conventionally what is used, and it is this formula. So it's the square root of both x2 minus x1 quantity squared plus y2 minus y1, that whole quantity squared.
Distance between the points.
Okay, so this is the definition of the distance between 2 points. And pretty much where did this equation come from? Why do we define it this way? This comes from the Pythagorean theorem, okay? So I can definitely go into this more and explain it to you if you want to come during office hours or just email me. But in the interest of time, I will not go into that explanation, okay? But in short, this comes from the Pythagorean theorem, okay? okay, which gives you the length of the hypotenuse of a right triangle. Okay, so that's the quick explanation. Okay, so let's just do some computations with this. All right, let's just do some examples.
What can you say that again? It comes from the hypotenuse over what? I'm sorry.
Yeah, so the distance formula comes from the Pythagorean theorem, and the Pythagorean theorem is the statement that given a right triangle with,
Uh-huh.
with legs A, B, and hypotenuse C, we have the following equation: C squared is equal to A squared plus B squared.
Okay.
And this formula up here, the distance formula, comes as an application, or it's motivated by the Pythagorean theorem.
Oh, okay. That makes sense.
So you can kind of see the relationship. We have two things being added to each other that are squared, and we want to solve for C. Well, we need to take a square root. That's why there's a big square root hanging out there.
Mhm.
So that's the quick explanation.
So those two equations are the same, or
No.
they're totally different. They're just
Oh, they're not the same, but they're not totally different. They are intimately related. But this is the Pythagorean theorem, which we'll do later when we do trigonometry. So this is used to solve for right triangles. But this, what I have written up here, this d equals the square root, that is the distance formula. Yeah. So they're not totally different, but they're not the same. They are related. Okay. Okay, so let's do some examples. Okay, so we're just going to do some computations here. So how we'll use this formula is I'll just say, all right, find the distance between, what points should we use? Let's do, okay, find the distance between -3, -1, and 2, 3. All right, so this is how a question will be presented to you for this. Okay, so essentially all I will do is I'm going to use the distance formula with -3 being x1, -1 being y1, 2 is x2, and 3 is y2. All right, so here's what it comes out to. So d is equal to a big square root. Okay, it's x2 minus x1. So I will do 2 minus -3 for the first guy. 2 minus -3, that quantity squared. Okay, that was the first piece of the distance formula. The second piece is y2 minus y1, that quantity squared. So y2 is 3, and I will subtract -1. All right?
Can I ask a question?
Of course.
How do you know like which one to put first? Does it matter? Like,
It does not matter which one you chose for x1 or x2.
okay, thank you.
Yes. Okay, good. And now we can just start simplifying the radicand, okay? So this first parenthesis, so 2 minus -3 is the same as 2 plus 3, which is 5. So I'll get 5 squared. The second parenthesis, 3 minus -1 is the same as 3 plus 1, which is 4, so 4 squared. All right, so I hope everyone knows that a double negative is the same as a positive. That's what I'm using there. Good, and we're almost done. 5 squared is 25, 4 squared is 16. Keep going. 25 plus 16 is 41. And this cannot be simplified any further. So that's the answer. All right. So everyone cool with this? All right. Let's do another example, okay? So how about this? Find the distance between what points? So 1, 4, and 11, 9. Okay, so as I said, it doesn't matter which one I make x1 or x2. They can be arbitrarily chosen. So I will make just this first one, x1 and y1, okay? And I'll make the second two, x2 and y2. But I do encourage you guys to swap your choices of x1 and x2 and convince yourselves you get the same answer, okay? That's a good exercise. Okay, so here we go. Let's just apply the formula to these points. So d is equal to a big square root. Okay, so the first thing you do x2 minus x1 quantity squared. So it's 11 minus 1 squared. Okay, x2 minus x1, that thing squared. Plus, there's a plus sign in between. Next, y2 minus y1, 9 minus 4 quantity squared. Excellent. And now this is not that hard. So 11 minus 1 is 10, and 10 squared is 100. So I'm skipping a step here. Hope that's okay. 9 minus 4 is 5, and 5 squared is 25. So I have 100 plus 25 in the square root. Good. So this is the square root of 125. Now, we do know how to simplify radicals now. That was from last class. So let's simplify this. So 125 is the same as 120, it's the same as 25 times 5. And now I use the multiplicative property of square roots to break this up as square root of 25 times the square root of 5. And what's nice is that the square root of 25 is 5. So we just have 5 square root of 5.
You still get the same answer. You just swap the points. The coordinates.
Can you say that again?
Will you still get the same answer if you swap the coordinates?
Yes.
Okay.
Yeah. So that's what I was saying before. You should work this out again with the opposite choices of x1 and x2, and you will get the same thing. And really, the reasoning for that, I'll explain it very quickly, is that if you have a minus b squared, that's the same as b minus a squared. Okay. Mm-hmm. Because b minus a will be the negative of a minus b, and when you square a negative, it becomes positive. So it's the same thing. So that's why which one you pick doesn't matter. All right, very good. All right, so we're moving along here. So the next thing we'll do is the midpoint formula. Okay. Midpoint formula. Okay, so pretty much all we're going to be doing here is given 2 points in the plane, say here to here. These 2 points will create a line segment between them. And we would like to find the coordinates of the midpoint of this line, okay? So we want to find the point on the line that cuts this line into 2 equal pieces, okay? We want to find the point that makes this segment congruent to that segment. All right, so we're going to be searching on how to find the coordinate of the midpoint. Okay, so that's what we'll be doing. Well, it's not that bad. So here's the formula. To find the midpoint, which is usually called M, capital M, just use this formula. Okay, so maybe this will look familiar. So capital M midpoint is, okay, oh, so sorry. So by the way, these coordinates have names. So this coordinate I'll call x1 comma y1, and this one I'll call x2 comma y2. So all you do is you do x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So that is the formula.
This one is also interchangeable, or?
Yes, so that was gonna be my next question. So my question is, does it matter what you choose as x1 and x2 and why?
No, because it's commutative.
Yes, exactly. That's exactly. So the reason being is because these numerators, x1 and x2 and y1 and y2, while x1 plus x2 is equal to x2 plus x1, okay? And that's by the commutative property of addition of the real numbers, okay? So yes, order does not matter because of the commutative property. Very good. All right, so let's just do a quick example using this formula. Find the Find the midpoint of the line segment. Find the midpoint of the line segment between, okay, here are the points, 7, comma, -2, and 9, comma, 5. All right, so I'm just gonna plug into the formula. There's not much else to do here. So the first thing we do is we do x1 plus x2 divided by 2. So that will be 7 plus 9 divided by 2, comma. Now do the same thing to the y coordinates, -2 and 5. So -2 plus 5 divided by 2. Good, now let's just simplify. So the numerator is 9 plus 7, which is 16. And the numerator of the second coordinate is 3. And we can do a little better on that first coordinate. 16 over 2 is 8. So this is 8, comma, 3 over 2. All right, so I just want to make a point here that our final answer is not a number. It is actually a point on the xy plane, okay? So the distance formula returns a single number, but the midpoint formula returns an actual xy coordinate, okay? That's why there's parentheses and a comma, all right? So just wanted to make that clear. All right, very good, very good. All right, so we're moving fast. Okay, next topic for tonight will be linear equations, okay? Linear equations. Okay, so whenever I introduce a term, I will always give the definition. So DEF for definition. So what is a linear equation? Well, here we go. A linear equation of one variable is of the form ax plus b equals 0, where a and b are real numbers, and we need to stipulate that a is not 0. Because if a was 0, then there would be no x term, and it's just not an equation anymore. It's just some silly statement. All right, so here are some examples. Here are some examples of linear equations. How about this? 2x plus 7 equals 19. That's a linear equation. And also 2x plus 1 equaling -9. Okay, so one should notice a difference between the definition and the two examples I gave you. Look at the definition. It's of the form ax plus b equals 0, but my examples don't look like that. But why are they the same? Can anyone quickly tell me why these are actually of the, they are in the correct form, the examples?
Can't you technically like move over what's on the equal sign side, like on the right, and then you could set it equal to 0 after?
Exactly. So for instance, on this first example, just like Julia said, I can subtract 19 on both sides, and that would create a 0 on the right side, which it then has the form of ax plus b equals 0. Yes. Very cool. All right, so how do we solve these things? All right, I think I hope this is somewhat familiar for you guys, but this is the gist of it. So our goal is we want to solve these linear equations for the x variable, okay? That's the goal. And what is the strategy? Well, essentially, just algebraically manipulate both sides of the equation, okay, with the intention or with the goal of isolating x, okay? That's pretty much the strategy. We algebraically manipulate both sides of the equal sign with our goal in our mind being, I want to isolate x. So what algebra can I do to get that x variable by itself, all right? So this will be very clear once we do an example, all right? So example, solve 2x plus 7, so this example from before actually, equals 19. All right, so the goal is to isolate x. All right, so first thing we can do is we can subtract 7 from both sides, okay? So let me do that, -7, -7. So this will give us 2x is equal to 19 minus 7, which is 12. Okay, everyone okay with that? And why did I subtract 7 from both sides? Because that will get us in the process of getting x by itself, okay? So we subtract 7, and next step will be to divide both sides by 2, right? 2, 2. And this will give us a final answer of x equals 6. All right, and the most important thing I can say with this is that whatever you do to one side of the equation, you must do to the other, okay? You need to maintain the equality, all right? So that's the most important thing. Because if you just do one thing to one side and don't do it to the other side, you've changed the value of the equation, okay? All right.
Just a quick question. If you like multiply by 1, but it's like a fraction that results in 1, then you can do to only one side, right?
Yes, definitely. So you're saying if maybe I multiplied the right side by like 3/3?
Yes.
Yes, definitely. So if I were to multiply one side of this by 3/3, I'm essentially just multiplying by 1 in a clever, in a different way. So no, that would not change the value of the equation.
Thank you.
Yeah, so we'll be doing that when we solve rational expressions. So that's good. All right, so let's do a slightly more involved example. So how about this? Solve, okay, so 4 multiplied by x minus 3 plus 12 is equal to 15 minus 5 multiplied by x plus 6. Okay, so remember the goal here is to isolate x. We need to do algebra and isolate x. So first let me distribute these numbers into the parentheses, okay? That'll be the first step. So that'll be 4x minus 12 plus 12 is equal to 15 minus 5x minus 30. Okay, this is by distributing. Okay, so is everyone okay from the first line to the second line? I just distributed the 4 and -5 into their parentheses. Good, so now let's combine like terms. So namely, I can do this -12 plus 12, and I can also do this 15 minus 30. All right, so that'll be 4x is equal to -15 minus 5x. All right, and what's the reasoning here? I just combine like terms. All right, so far so good. And remember, the goal here is we want to isolate x, okay? We want to get all of our x's to one side. So how about I add 5x to both sides? Okay, so that'll give me 9x is equal to -15. And finally, divide both sides by 9. I'll get x is equal to -15 over 9. All right. So I hope this is okay with everyone. No one's asking questions just because it's super easy, but I hope it's okay.
Professor, would it be fine to put a decimal instead of a fraction?
You know what? I would prefer fraction because if you go to decimal, that's just an extra step for you guys to do.
Oh, okay.
Yeah, because you divide both sides by 9. That's it. You have your fraction already. And if going to decimal would just require to go to a calculator or something. Seems like more room for error. So I would prefer fractions. Yeah.
Okay.
Good. So I will move on if that's okay with everybody. Okay. Next thing we'll do is solving rational equations. Okay, so this is a generalization of solving linear equations. Okay, so we'll be solving rational equations. So this is a step up from linear equations. Okay. All right, so of course I need to define what a rational equation is. So DEF, definition. All right, A, rational expression. Rational equation. So that should be rational equation. A rational equation, here we go, contains at least one rational expression. Okay, so we know what those are now from last class. Where the variable appears in at least one denominator. In at least one of the denominators. All right. So hold on, I wrote this a little sloppy. Let me just rewrite this. Okay, so it's an equation, so there's an equal sign. There will be a rational expression present, which means that there's going to be a quotient of polynomials, and you'll have a variable in one of the denominators. Okay, so that's the abstract definition. We need a concrete example here, so let's get to that. So here's an example. 7 over 2x minus 5 over 3x equals 22 over 3. Okay, so just note here how we're satisfying the definition. We have variables in the bottom of the fractions. We have 2x and 3x, and we have rational expressions. Okay, because 7 over 2x and 5 over 3x are rational expressions. All right, so how do we solve this? All right, I'm just going to go straight to the steps, okay, and then we'll use the steps. Okay, so here are the steps. All right, 1, we factor all denominators, okay, if they're not factored already. Factor all denominators. Okay, step 2 will be to find the LCD. So find the LCD and just recall that's the least common denominator, okay? So I will always write LCD just because it's a little quicker. Okay, and now here's probably the most exciting part. You have to multiply both sides of the equation by the LCD, okay? Multiply both. Sorry, my dogs are going crazy. So multiply both sides of the equation by the LCD, okay? And why do we do this? Well, just quickly said, this will clear all of the fractions. Okay? So when you multiply both sides of the LCD, you essentially get rid of all the fractions, and then we're left with a linear equation to solve. All right? So solve the remaining equation, okay? So basically, we reduce this down to just solving a linear equation like before. All right, that was the point of multiplying by the LCD. All right, and just a very important step here. You need to exclude x values, okay, which produce a 0 in any denominator, okay? So that's your final step. Okay, so after you solve that remaining equation, you need to just look at your x values and just check to see if any of those x values will produce a 0 in the denominator of any of your fractions. All right, because in math, you cannot divide by 0, okay? It's undefined. All right. All right, so let's do an example here, okay? So let's do solve 2 over x minus 3 over 2 equals 7 over 2x. Okay, so the first step was to factor all of the denominators, but they're already factored, okay? So the next step would be to find the LCD, okay, the least common denominator. Okay, so the LCD, it should be kind of clear. The LCD is simply 2x, okay? So you look at the LCD of all of your fractions, not just on one side of the equation. You inspect every fraction present and find the LCD, all right? The LCD is 2x. So we now multiply both sides by 2x, all right? So that's not too bad. So I'm just gonna be I'm gonna move slowly here and just write everything out. So we have 2x, 2 over x minus 3 over 2 equals 7 over 2x multiplied by.
It has to be with all the denominators, including the one to the right.
Yes.
Okay.
So when we were finding that LCD, we had the fraction on the right considered. We were considering that one. Yes. Good. So now we multiply both sides by that LCD. All right. And what does this look like? All right. So this should just be, okay, 2x, 2x. I think this is just 4 minus.
Oh, right.
Yeah, 4 minus 6x over 2 is equal to 7. I think that's right. Does everyone agree with what I just got? Okay. Good. And now we just need to solve for x. Okay, so we know how to do that. So just to make things a little easier, so this negative 6 over 2x, that's the same as negative 3x. So this is 4 minus 3x is equal to 7. Okay, now let's subtract 4 from both sides. So I have negative 3x is equal to 3. And then I divide both sides by negative 3, and I'll get x is negative 1. All right, so that's the answer. So I hope everyone is okay with that. So we need to just go back and inspect whether negative 1 will cause us to divide by 0 anywhere. Very important. So let's go back to our original equation. If I plug in negative 1 into any of these fractions, it does not cause division by 0. So we're good. All right. All right. So I'll just be explicit. This is a solution because it doesn't cause us to divide by 0. All right, so that's kind of like the big no-no in mathematics. Can't divide by 0. Okay. Where are we at now? Let's see where we're at. say we keep moving with some examples, okay? Okay, so how about this? Let's solve x over x minus 3 is equal to 5 over x minus 3 minus a half. Okay, so I just want to make sure my notes are in order here. Just give me a second. Okay. Okay, so the first step is to factor everything. There's nothing we need to factor here. Everything's factored already. So now we just need to find the LCD, okay? The LCD. Okay, so would anyone like to tell me what the LCD is of all three fractions? That's what we need to consider. So the LCD is...
Six.
Would it be x minus 6?
Yes, I would write it as without distributing the 2, but yes. So you said 2x minus 6, which is equivalent to this. Yes, good. So that's the LCD. And you can always get the LCD just by multiplying all of the denominators of the fractions, okay? Good, so now we just multiply both sides by this, okay? So let's do that. So we have 2 times x minus 3, okay, x over x minus 3 is equal to 5 over x minus 3 minus a half, and multiply that by 2 times x minus 3. Okay, so all I've done here is just multiply both sides of the equation by the LCD, all right? So this will clear all the fractions, that's the whole point. All right, this is not too bad. So this x minus 3 and that x minus 3 will cancel completely. So we're just left with 2x on the left side. So that's nice. How about the right side? Okay, so we have an x minus 3 here. That'll cancel with that guy. So we're just left with 10 for that first term. And on the second minus 1/2 term, the 2's will cancel. So we'll just be left with minus the quantity x minus 3. Okay, so that can be a little tricky. So just be very slow when you do this step. All right. So to check to see if you did this step right, you should not be left with any fractions. Fractions should be gone at this point. All right, good. And now we've just reduced the problem to solving a linear equation like before. So this will be 2x is equal to 10. Let me distribute the minus signs. It'll be negative x plus 3. This is the same as 2x is equal to 13 minus x. Right? Yep. Now let me add x to both sides. So this is 3x is equal to 13. And the final answer will be x is equal to 13 over 3. All right. All right, so we need to make sure this will not cause us to divide by 0. Well, just notice the only x value that would make us divide by 0 is 3. And that's not our solution. Our solution is not 3. So this is a legit solution. All right. Because we will not divide by 0 if we input this value into our equation. All right, so that's very important. All right. All right, let's do a, so how are we on time? We have 40 minutes. Yeah, okay, so let's do one more example here. It'll be just slightly more involved. And then we'll move on to the last topic of the night, and hopefully we'll be done early, okay? So here we go, last example under this heading. Let's solve 2 over x plus 1 minus 1 over x minus 1 is equal to 2x over x squared minus 1. Okay, so remember the first step for these types of questions is to factor, okay? So first we need to factor the denominators. First factor all denominators. Okay, so which one do I need to factor? Well, x plus 1 is already factored. X minus 1 is factored, but x squared minus 1, that can be factored.
Yeah.
Right? So let me just rewrite the equation with that with the factorization of that. So 2 over x minus 1, 2 over x plus 1 minus 1 over x minus 1. So does anyone want to give me the factorization of x squared minus 1?
It's literally the same thing, I think. It's a combination of both of them, the denominators. It's a difference of 2 squared.
Yes, so you said it, difference of 2 squares. So how do we factor a difference of 2 squares?
So it's x plus 1 and x minus 1, literally. I mean,
Exactly. Very good. All right, so we just factored that denominator. Good. Next step, find the LCD. The LCD is, okay, so the LCD is just going to be x plus 1 multiplied by x minus 1, okay? That's not that bad. Okay, so I will multiply both sides of this equation by the LCD. So let me just copy paste this. Okay, good. So let's do that. So the left side I will multiply by x plus 1, x minus 1, and the right side I will do the exact same thing. X plus 1 times x minus 1. All right, so let's just take a second to write this neatly. So we're going to multiply both sides by the LCD. All right, so now we need to be careful. Now we just need to take our time. So on this first term, 2 over x plus 1, the x plus 1 and the x plus 1 will cancel. So all we're left with is 2 times x minus 1. All right. Second term, the x minus 1s will cancel, and we'll just be left with minus x plus 1. Okay. Okay, and just make note, I'm keeping that minus sign outside of the parentheses. Okay, I didn't distribute it in yet. All right. And how about the right side? Well, the right side is very nice. The x plus 1 and x minus 1 will cancel completely with that one. So the right side is just 2x. All right. So let me just say this again. You'll know that you're on the right track is if you're left with no fractions. Right? And we're left with no fractions. We're just left with a linear equation. All right, so let me just solve this very quickly. I'm going to distribute the 2 and negative 1 into those parentheses. All right, so 2x minus 2 minus x minus 1 is equal to 2x. All right, how about combining like terms? So this will be x minus 3 is equal to 2x. What else? What else? And then I can, yeah, so there's a few things you can do. Yes, yeah, so you can subtract 2x from both sides and then add 3 to both sides. You'll get that x is equal to negative 3. Okay. All right, so any questions on the process? So there will be questions like this on the homework for you guys to practice. Really, all you need to do is just go up to the set of steps. All right, just follow these steps one by one, and it will be okay. All right, they shouldn't be that hard. All right, good, good. All right, so we're reaching the end here. So let's talk about somewhat disjointed from the previous topic, but let's talk about the slope of a line, okay? That'll be the next heading. All right, the slope of a line. All right, so of course, we will have a definition, okay? Okay, so the slope of a line, usually denoted with the letter M, okay, represents represents the change in y over the change in x. Okay. And so that's kind of just like an intuitive definition. And here's the formal definition. Given 2 points, x1, comma y1, and x2, comma y2 on a line, so they both live on the same line, the line's slope is given by. Okay, so what is the slope given by? So m, so a lowercase m is usually the letter we use for slope. So it's just going to be y2 minus y1 divided by x2 minus x1. Okay, and again, just like with our previous things with x2s and x1s, the choice does not matter, but you need to stay consistent, okay? So what I mean by that is if I chose this to be x2, I have to choose the thing next to it to be y2, all right? So you need to be consistent with your choice. All right, so I'm just gonna rattle off some facts about slope, okay? So, so this is just some quick facts about slope. So the bigger the slope, the more rapid the change in y.
Is that where the word steeper comes in?
Yes, that's literally the next thing I'm gonna write.
Oh.
So, very good. So graphically, this means the line gets steeper.
Oh, that makes sense.
Very good. Okay, so, all right, so on a graph, this means this, if the slope is getting bigger, if the slope is big, then the line is gonna be pretty steep, okay? And let's just talk about the sign of a slope. So positive slope will imply, so that arrow just means implies, the line slants to the right. Okay, and how about negative slope? Negative slope. So this arrow again just means implies. Negative slope will imply the line slants to the left. Okay, and we will go through examples of all of this, all right, just to see what it looks like on the XY plane.
I have a quick question. If the line is completely vertical or horizontal, is it a positive or negative?
Can you just say that again? You said horizontal or vertical?
Yeah, like completely horizontal or completely vertical. Like it's not length anywhere.
Yes, so that's a great question. And we are going to, do I have that here tonight? Yeah, so I was going to talk about that in the next class on Monday. But essentially, if you if you have a horizontal line, the slope is 0. And if you have a vertical line, the slope is undefined.
Okay, thank you.
Because essentially, if you had a vertical line, then the x2 and the x1 would be exactly the same, and it would cause you to divide by 0. So that's why the slope of a vertical line is undefined.
Okay, thank you.
Mm-hmm.
You would either have a y or x intercept.
Yes, there will be a y or x intercept. Okay, so example, find the slope of the line that passes through the points. Okay, -2, oops, nope, 2, comma, -1, and -5, 3. All right, so we just need to use that formula. So remember, m is equal to y2 minus y1 divided by x2 minus x1. Okay, so which one should we make x2 and y2? Well, let's just do this. So we'll make that x2, that y2. We'll make this guy x1 and y1. Okay, so the numerator of this fraction ought to be 3 minus -1. Okay, y2 minus y1, 3 minus -1. And the denominator should be -5 minus 2. -5 minus 2. Very good. So just work this out. This will be 4 over -7. And if you can just bring that negative sign in front, it'll be -4 over 7. Yeah. All right, good. So that's slope, okay? All right, good. All right, so now we arrive at something very, very important, which you will use in calculus if you decide to take calculus later. So this should also look familiar. So definition, the slope intercept form of a line is y equals mx plus b. Okay, so what's m and b? I need to tell you what those letters mean. Okay, here, m is the slope. M is the slope of the line. And as Saeed said earlier, b is the y coordinate of the y-intercept. Okay, so this should seem very familiar. At least the phrase itself, y equals mx plus b, that should kind of ring some bells in your head from your past, hopefully. All right. So this is called the slope-intercept form of a line. So it's very, you can see why it's named that. Well, because the slope and y-intercept are both present in this form of a line. Okay, all right, so just let me see what I have here. Okay, so just quickly, in the example y equals 2x plus 3, this has slope m equaling 2, okay, because that's the coefficient of x. You can just read that off. And y-intercept. So I'm going to put the y-intercept into the xy coordinate form, 0, 3. Okay, and where am I getting 3 from? That's just this constant term hanging out. Okay, the plus 3. So that's the y coordinate of the y-intercept. All right, so I hope that's okay. All right, so why do we care about this form of a line? Well, it actually makes it really easy to graph lines, okay? Given this form of a line, it's very easy to graph. So that'll be how we'll end class, okay? Graphing a line using that slope-intercept form. Okay, so that's how we'll finish tonight. So just recall, slope-intercept form is y equals mx plus b form. Okay. All right, so how do we do this? Okay, so I just have to write a bit, and then we'll get to an example. So, okay, so in the previous example, y equals 2x plus 3. Okay, the slope, recall, was 2. The slope of 2, okay, which you can also rewrite as 2 over 1, which you'll see why in a second, tells us that, hold on, sorry. Okay, tells us that there is a 2-unit change in y, which we'll call the rise, as there is a 1-unit change in x, which we'll call the run, okay? So where am I getting 2 and 1 from? So 2 is just the numerator of this, and 1 is the denominator, okay? All right, so how do we graph this line? Okay, so here we go. So to graph this line, first plot the y-intercept, okay? First plot the y-intercept. So we figured out the y-intercept was 0, 3. Okay, so let's do that. Actually, let me write first, and then we'll graph. Okay, first plot the y-intercept, then move 2 units up and 1 unit to the right to obtain another point on the line. Okay, so this is that whole rise over run business. Okay. Okay, so let me first plot the y-intercept. So the y-intercept is 0, 3. So I just go up 3 units on the y-axis. Now, to get other points on this line, I move 2 units up and 1 unit to the right, okay? So here's the y-intercept. Now I'll move 2 units up, 1, 2, and then 1 to the right. Good, now let me do that again. 2 units up and 1 to the right. Very good, and now just connect your dots with a line, okay, and you're done. Alrighty, so I hope that's okay. Okay, and so there's something else that needs to be said. Alternatively, we can also move 2 units down and 1 unit to the left from the y-intercept. To obtain another point on the line. Okay, so lots of writing, I apologize. Okay, so what I've written here is that as well as going up 2 and to the right 1 from the y-intercept, I could have also have gone down 2 and to the left 1. Okay, and that would give me this point right here. All right. So that would be useful sometimes. Okay, very good. So let's do another example here. So this is kind of how the question will be presented to you on homework or tests. So graph y equals negative . So graph y equals negative 2 over 3x plus 1 using y-intercept and slope. Okay, so pretty much just using the set of steps from this motivating example up top. Okay, so first of all, we need to find the slope and we need to find the y-intercept. So first of all, the slope is negative 2/3 and y-intercept is 0, 1. Okay? So this is not bad. So what does this slope tell us? So the slope of -2/3, okay, tells us to move 2 units down, okay, because there's a negative, it's -2, so move 2 units down and 3 units to the right. To the right from the y-intercept to obtain another point on the line. Okay. Okay, good. So let's get graphing. Okay, so I first go to the y-intercept. So I'll go to 0, 1, which is right there. And from here, I move 2 units down and 3 units to the right. So 1, 2, 3, and then I'll move, okay, yeah. Sorry, you move 2 units down. Yes, 1, 2, and then 3 to the right. Okay, so 1, 2, 3. So that'll be right here. And alternatively, I can move 2 units up and 3 units to the left to get another point. So 2 units up and 3 units to the left. That'll put me right here about. All right, and then you just connect the dots. Oh, that's a bad one. So, yeah, so just connect the dots and you get your line. Okay. So I hope that's okay. So just please let me know if there are any questions. So one final example. Okay, so note, sometimes we need to algebraically manipulate our given linear equation into y equals mx plus b form, okay? So sometimes we're not going to be given our equation in y equals mx plus b form, and we'll have to do a little bit of algebra to put it there, okay, before graphing. All right, so what does this look like? So here we go. Here's an example. Graph 2y plus 2 is equal to x. Okay, so this is not in y equals mx plus b form, therefore we cannot read off the slope and y-intercept immediately. So we need to do some algebra. Okay, so first do algebra. Okay, so we want to put this into y equals mx plus b form. So we can do 2y is equal to x minus 2. And now divide both sides by 2. I'll get y is equal to 1/2 x minus 1. All right, and that's our y equals mx plus b form. All right, good. And from this, it's easily attained that the slope is m is equal to 1/2, okay? And y-intercept is 0, -1. All right, so I hope everyone sees why I needed to do algebra. I needed to put it into y equals mx plus b form so I can easily read off the slope and the y-intercept, because I was not able to do that in the equation's original state. Okay. All right, good. And now graphing is a really easy thing, so I'll just do this very quickly. I go to the y-intercept, which is 0, -1. So I go up 1 and over 2, or I could go down 1 and to the left 2. Okay, so it's going to look something like that. Connect the dots, and you're good. All right. So that's all I have for tonight. I will stick around and answer any questions. And homework number 2 will be available after once I finish up here, and that's due on Monday. Okay. So the next homework will be due this Monday.